Hi everyone. Hopefully you can hear me. If you can't hear me, throw something on the chat line, and well, if you can't hear me, I have no idea what to do. So hopefully you can hear me because I'm just going to continue on regardless. Welcome to the APAC OUC webinar series, put on obviously by Francisco, who's done an amazing job putting a fantastic set of slides and everything together, or a series of talks together. Hopefully this will be the start of something huge that happens every single year. You've seen from hopefully the promo slides that this thing goes on literally for for all of July, all of August, just with an amazing array of talks, and I'm thrilled to be kicking it off. But that's enough of me. I'm going to flip over to the slides, mainly to keep I'm in Perth, which is a million miles from anywhere, so I'm going to try to keep the bandwidth down low by ditching myself off the webcam and flicking straight to the slides. And we'll charge along. We'll go pretty much for most of the hour, and then effectively, if you have questions afterwards, come see me on AskTOM or get in touch with me on Twitter, etc. You'll get my links. The slides will be available in the next few days. Anyway, let's flick over to the slides and we'll get going. So I will warn you that there's actually, I was doing a test earlier this morning, there's a latency of about 10 to 15 seconds between the slides. So if you're throwing in chat questions, I probably won't tackle them because it'll have to make us go back several slides, but we'll do our best. Anyway, I'll start with the standard slide, the Oracle banner. I work for Oracle now. I've been an Oracle person in the company for about 2 years now, and I was working with Oracle technology for about 25 years, somewhat embarrassing to say before that. I'm from Perth in Western Australia, which is a long way from anywhere, unless you also live in Australia, but it's great to be part of a culture where we can actually now reach globally with webinars and things like that. I do enjoy the travel. I've just recently been in India, but the ability to virtually travel via webinars is also great in terms of reaching out to people. This is how you get in touch with me. I have a Twitter account, Connor McD, my blog, connormcdonald.wordpress.com, and a YouTube channel. I've started getting into YouTube now because recently I had to unblock my sink at home, and I realized the first thing I did was go onto YouTube and type in how to unblock my sink. So YouTube has become a place now where people like to find information and solutions to problems. So we're trying to do the same thing now with technology. For those of you that aren't in the US, I know Twitter's perhaps not so popular outside the US, but I encourage you, anyone that's not on Twitter, to get onto it, and of course to follow me, but mainly for the fact that many of the US product managers will do their major announcements via Twitter. So if you want to stay informed with Oracle technology, make sure you jump onto Twitter, even if you're not an active participant. Just following the right people on Twitter will hope you get you some good education and some good insight into what's coming inside Oracle. And this is what I do for a lot of the time. I look after the AskTOM website. Tom Kite retired in 2015, and ever since then myself, Chris Saxon and Maria Colgan have been looking after the site, trying to help the developer community and the DBA community with solutions to hard to solve problems. It's the highlight of my day working on AskTOM because it's like free training. I get to work with all sorts of interesting products and technologies. So this session is called 12 Things You Will Love About 12.2. I'll put the word approximately in there as a caveat. We'll simply chug along as we can. When I run out of time, we'll call it quits there, but the slides will be available for anyone that needs them on the asktom.oracle.com website. Now, why have I agreed to participate in this for Francisco? Well, besides the fact that he's a good mate, one of my job descriptions inside Oracle is I'm part of a thing called the Developer Advocates team. There's 5 of us in the team, and our job is to actually make you more successful with Oracle. Now that might sound a bit philanthropic, but the reality is, obviously, if you're more successful with Oracle, then you're more likely to invest in more Oracle products. So hopefully we can all win by being very successful with our Oracle applications. You might be thinking, well, why are you here? Because after all, it's all well and good to go to a 12.2 features talk and get very, very excited about all the 12.2 features, and there are some awesome features we're going to cover today. It's all well and good to be excited about it, but the reality eventually sets in the moment the webinar finishes. And that is, we go back to our little desk-side cubicles, and often the air conditioning is very, very poor, and we sit there and we're not having a great time. And more importantly, we're stuck on some terrible release of the software. Something that's almost de-supported by now or is de-supported, perhaps on a platform that's no longer the sort of platform du jour anymore. And so often it's easy to get disenchanted and saying, why would I bother learning about new features when it's going to be years? In fact, This year is 2017. The reality is for many of us, it'll be 2021 or even 2022, before our manager walks in and says something like, I've heard about this really interesting thing called 12C. Maybe we should explore it. It's comical, but it is the reality. We often lag behind the latest releases. You still should be here, in my opinion, and I'll tell you why. One of the things that it's important to do is to always know what's coming in the next release of the product. Way back in Oracle 7, I wrote myself a beautiful queuing mechanism, crafted it over the best part of 12 months, only to realize that advanced queuing came for free in Oracle 8.0 and did a much better job than I could do because obviously I had access to the internals of the kernel. So you don't want to be reinventing basically the wheel. In particular, if you try reinvent the wheel, often we invent one that's actually slower, not particularly good, and just a code maintenance nightmare in future releases. So make sure you know what's coming in the latest release. Use the latest release of the documentation, even if you're not on those releases yet. That way, you're always abreast and informed about what's coming. Now, there's a whole lot of stuff in 12.2, and you can actually get started right now. Here's my little bit of marketing that I have to do. One of the options is you can choose to install nothing. Literally jump onto cloud.oracle.com/try it, get yourself some credits. It's as easy as getting an SSH key, bang that into SQL Developer, and you're off and running with 12.2 on a cloud database for free. Let you trial and explore with the software, nothing to install. You can choose to install a little bit of something, and that is we have these pre-built developer VMs that you can get off that URL you can see there. It's a fully configured VirtualBox VM with 12.2 inside it and SQL Developer and ORDS as well, and some hands-on labs. So it's a great way of just getting in there and actually playing with the technology without having to worry too much about the installation. For those DBAs that are on the call, obviously you can choose to install lots. You might want to learn about the actual configuration and installation of the product. So in those cases, you can actually download the full software, run it on your own VMs, and see how you go. Plenty of ways to explore. Now, before we get started, there's the obvious safe harbor statement that you see from every Oracle speaker. Pretty much I consider that a waste of time if you're listening to a talk by someone from Australia. Because let's face it, how did Australia get started? It didn't get started by founding fathers or anything like that. It got started because the world sent its convicts there. So rest assured, I descend from convicts, criminals, and people of generally bad behavior. So please don't trust anything I'm saying. In fact, never trust anything any speaker is saying on any webinar series. Take these examples away, test them on your own systems, and that way you can actually have confidence that these things work as they do on the box. If you find things that don't work as I say today, please let us know on AskTOM, because if it is a genuine bug, we can make the product better for everyone. The other thing I have to say is it's not much use talking to me about licensing. When I joined Oracle, I discovered that licensing decisions are made at about here in the company, up around the Larry Ellison level, not exactly where I have access to. In fact, if we scroll down through the Oracle organization chart, you can pretty much see where I sit in the Oracle company. Pretty much at the bottom. I'm at the same level as a bucket and as a cabbage. So the reality is, no good asking me about licensing, because even if I could give you information about licensing, the likelihood of it being correct is pretty low. Now, time is short and I've meandered on long enough. So if you have questions, please jump onto AskTOM.oracle.com. That's our logo for the time being, because Oracle turned 40 this year, and I'm thrilled to put that little logo out there. But let's get started. Feature number one that we've been waiting for a long time, longer names, finally. Those of you on 12.1 might have seen that some of the data dictionary views actually got extended way back in 12.1, but the names were still limited to 30 bytes. In 12.2, we have 128 bytes now for columns, tables, usernames, etc. In fact, pretty much the only thing that's not extended now is table space names are still capped at 30, but almost everything else in those namespaces is now 128 bytes. For me, that is super cool. I'm very impressed with that. I've been working with Oracle about since Oracle 6, and so this is a revelation to me. In particular, and there's even though there's a bit of a pun here, it's a genuine feeling of mine that if you have longer name capacity for table names and column names, they do give better meaning. I'm a big fan of code being self-documenting as much as possible. So column names should accurately describe what their function is or what the attribute they're modeling is. Table names the same. So the longer you have, the more flexibility you have. In particular, in the old days, one of the things that used to be really annoying to me was a lot of systems got migrated from, say, mainframe systems, which had things like 8-character names. So as a developer, you'd be given a request like, can I get a comma-separated file of the chart of accounts? But when you go look at the list of tables in your database, it looks something like this. And you had to go actually look up a hard copy book to find out that T004 was actually the chart of accounts. This is a legitimate example from a software product that's out there today. The other thing that used to really get me frustrated was if someone did go to the effort of give a really nice table name, for example, finalized annual budget stats. As a DBA, I might adopt my company standard and do something like, I'm going to have a primary key, my company standard is _PK at the end, but that would be the few characters that would tip me over the edge to 31 characters, and I wouldn't be able to do it. So now I had to actually sort of circumvent my standards to come up with certainly bits and pieces, certain naming standards that didn't really match the standards. Frustrating stuff. So longer names is great, but let's face it, the moment you give someone an inch, they generally take a mile. So what I'm scared of is that you're going to have something things like this. You get these people who are, sort of programmers who love mixed case and they love ridiculously long names. And I'm having a little dig here at some .NET programmers here that I used to work with. But this is the risk you run when you start having 128 bytes of column names available to you. You could even put emojis in there if you really wanted to, but hopefully no one ever will. In particular, those kind of things start causing problems when you have existing scripts that do things like list out the table name columns and stuff like this. Here's my standard query against all tab cols, and it's been totally messed up in SQL+ because of these massively long column names. Well, here's my solution for you, and this is the first bit of fun for hopefully the session. I'm going to create a DDL trigger such that only certain people get access to the long column names. What I'm going to do is I'm going to look in your DBA role privs and see if you're a senior developer. If you're not a senior developer and your object name is then greater than 30, I'm not going to let you do it. So let's look at that in action. I connect as a junior developer. They can create a table called employees, no problems at all. But if they try to create a table called employee ratings benefits before salary review, well, my trigger jumps in and says, that's too long. That's pretty cool. Of course, if I connect, well, I'm a senior developer and I'll be able to use any kind of long names I want. So there's a bit of fun for you. You can actually control the length of names based on people's privileges. Obviously, really, we'll probably let everyone have a reasonable length. Feature number 2. So we've got longer names covered. We end up with tables that look like this. Someone's given us a lot of effort into giving some nice long column names. That's great, until your application starts to crash. And there is a risk when you start allowing larger sizes of varchar2s, whether it's column names or anything else. I might be using something like the listag function to concatenate all those column names up into a meaningful string or a concatenated string. Now that the columns can be more than 30 bytes long, having them up to 128 bytes long and then concatenating them might blow my varchar2 limit. And in this case, in trying to do the concatenation, I've blown it up. That is a tough one to solve when listag falls over. Because if we look at an example here, what I've got here is I'm doing a listag, sort of a running total of listag. So when I get to the first column of empno, the listag value of cols is empno. When I get down to ename, the listag value is empno, ename, and so forth. Let's assume that I can go up to the value of commission, so effectively our second last column there, before listag would fall over. Obviously, normally it would be a lot longer, but let's assume that after commission, the addition of the varchar2 of depno would actually blow up the listag function. I would need to stop one column short. I need to stop at the commission value, not at department number. How do I actually know? How do I actually know that I'm about to go over the limit without actually trying to go over the limit? That would then be a problem. We've solved this in the past by going back to first principles, sometimes a pipeline function to do a manual implementation of listag and checking the length that it's about to become and then stopping if necessary. In 12.2, we've made some improvements to that by improving the overflow handling in the listag function. We now have this optional clause on overflow truncate. What that does is by default, we concatenate columns up into the limit, and then we get 3 dots, or the ellipses. It actually is 3 dots though, followed by the number of characters we have to truncate. That's the default handling. But the key thing is it didn't fall over. It actually just truncated the data. You get control over those attributes. For example, I can do on overflow truncate and then the string more, and the 3 dots are replaced with the string more. Or I can choose keep the string more but don't have the count. So I then lop off the number of characters that were going to be truncated. Or I could even do truncate with the null string or empty string without the count, and that is just a stock standard truncation. I go up to the limit of varchar2 and I simply stop. So you've got that flexibility in your own control now to make sure that ListAg gives you the output you want without it crashing. Feature number 3, multi-tenant. And there's my little graphic of a multi-tenant database, the familiar USB database that is on every Oracle slide that we see nowadays. We now have some features at the pluggable level. Now in 12.1, we said you should use multi-tenant. It is awesome. We said it, and we pretty much shoved that down everyone's throat. We had so many presentations about how cool multi-tenant was. But then there were all these caveats we threw in as well. We said, would you like to flashback a pluggable database like you would a normal database? Well, unfortunately, no, you can't do that. And then people would say, there's this cool new feature called temporal validity in 12.1. Can you use that with a pluggable? No, you can't do that either. Or you'd like to use Flashback Data Archive, which is an awesome way of doing auditing in your database. Nope, can't do that in a pluggable as well. A little bit frustrating because multi-tenant obviously is the long-term future. And there were other things you couldn't do in 12.1 at the pluggable database level. In 12.2, a pluggable database really is almost like a database in its own right, which I think is really cool. Here's an example. I'm dropping a table called customers. The table has been dropped, and then at some point it suddenly dawns on me that I was connected to my production database as opposed to my test database. And obviously that would be somewhat of a bit of a problem, in particular for my career. What we have now is per pluggable database flashback. Here's an example, and this looks just like you would do normal flashback. I can create a restore point. I've called it in this PDB. I've created a table called new tab after I've created the restore point. How does flashback work in a pluggable in 12.2? Just like flashback in normal. I'd simply close the database, flashback pluggable database PDB2 to the restore point. That was taken before that table was created. So now when I try describe the new table after I reopen the database, it has been erased from existence. It has been flashed back. So flashback database at the pluggable level works pretty much just like flashback database at the normal level now in 12.2. The other issue that we had with multi-tenant databases was part of the objective of multi-tenant is obviously the ability to consolidate multiple databases to have a smaller server footprint and take some advantages of some other features as well. One of the things that might happen there is you might want to consolidate various databases that have different character sets. You couldn't do that in 12.1. In 12.2, we have per pluggable character sets now. So I can, for example, use the containers clause to look at the character set across all my pluggables. And you can see there that pluggable number 4 has actually got a different character set to the others. This only works if your container database is AL32 UTF-8. In 12.2, that is the default. And I would hope that it's been a long time anyway since anyone's created a database that isn't UTF-8. Because the reality is it's so easy to get international characters now, even in your most simple of databases. So UTF-8 is obviously the way to go, and you'll need it if you want to have consolidated multi-character set pluggables. Feature number 4. Here's my sales table. As with most tables, it'll probably have a primary key on it, the sales primary key. And then as we start using this table, someone might say, well, I'm doing queries by customer ID, so I need an index on the customer column. And then someone else says, well, I need to do date range queries, so I need an index on the sales date column. And then it might be, I've got indexes, I need an index on the product column. And as tables evolve over time and they become more and more popular for ad hoc query in particular, what tends to happen is you get this proliferation of indexes just flying through. And next thing you know, you've got 30 indexes on the table, many of which might have been used for a one-off requirement. They might have been used for ad hoc query, not as part of your application. Which ones are actually in active use? How do we tell? Now you might be thinking I'm leading on to a feature that already exists, and it's true, we've had a crack at this before. This is how to tell if a index has been used in your database. Back in Oracle 9, we introduced this thing called alter index table, alter index monitoring usage. And what would happen was you would do this. You would say alter index monitoring, and at that point, the index would then appear in the $$ object usage view. And we can see there that we have the index name, table_pk. We say that it's monitored because we've done alter index monitoring, but we say that it's used no. And what that means is, effectively, we can only detect whether an index is used in a yes or no fashion. Let's explain that a bit better. I now do a select star from table where the primary key column equals 1. That will use effectively the primary key index. Now when I go query $$ object usage for that index name, the used column has toggled over from no to yes. But this is all we could really do in Oracle 9. Effectively, monitoring would simply say the index has been used yes. We didn't give you any information about how many times it's been used, when was the last time it was used. And there was one other critical problem with index monitoring in version 9 and onwards. This detection was done as we parsed queries. What does that mean? Let's look at an example now where I've got a child table that refers back to a parent, and that relationship is on delete cascade. So what we've got is a child table here referring back to a parent table with an on delete cascade. To support that delete cascade, we've created an index on the child table. When I do delete from the parent table, what happens is we look at the execution plan. It says I'm doing an index range scan on the parent primary key. Nowhere in the execution plan does it say that I was accessing the child index. Now, under the covers, we can be pretty confident it is. Once we do a delete from the parent, we have to jump off to the child table and delete all those child rows that refer back to the parent due to the on delete cascade foreign key. We use the child index for that, but because it didn't appear in the execution plan, when I go look to see if that child foreign key index was actually monitored, the database says no. This is the issue with index monitoring in earlier releases. Because we detected at parse time, if the index is used only at execution time, i.e. not in the base execution plan that we saw there, we might mistakenly go drop that index. When I go drop that index on the child table and then try redoing my delete, what do I get? I get an hourglass because I've created a big problem. I might also create some locking issues by dropping that index. Index monitoring in the early releases had a few issues. So what we've done is we've had a fresh and hopefully better look at this in 12.2. There's now a view called DBA index usage. And how do we activate it? Well, by default, it's always on. Just like back in Oracle 8i, we introduced a thing called table level monitoring, which you had to explicitly activate. And then we worked out a way of making it efficient enough to actually have it on all the time. It's the same with index monitoring in 12.2. It's always on. And we get some useful information. We get some totals in terms of how often the index was used, and we get some histogram style information to give us a much better information about how and when this index is used. And obviously one of the critical ones is when the index was last used. In this case, 17th of August 2016 on my slide. One of the key things here is the example I've chosen here is that child foreign key index, the one that didn't appear in the execution plan. So even if we're using an index that doesn't appear in an execution plan, for example, on delete cascade, it'll still get picked up by DBA index usage. So it's actually being detected at execution time, not at parse time. As I said, it's about execution. One thing I want to stress, when I first blogged about this feature, I got a lot of friction back from people saying, it doesn't solve every single index problem. What if an index is needed for locking? What if an index is needed for other bits and pieces? What if an index is only used once every 5 years and you drop it because it wasn't detected in those 4 years? I stress, any kind of monitoring in the database is designed to help you, not replace you. It's not meant to take away the decision-making process. And here's an example for you which actually proves the point. Indexes can be involved in more than just execution. An index can be important even if it's not picked up at parse time and even if it's not picked up at execution time. Let's create a table called T1 it's got two columns, C1 and C2. We're doing a select count star from T1, where C1 equals 12 and C2 equals 12. And we can see the result is 200. So we know in advance that that query returns 200 rows. What does the optimizer think? Well, the optimizer doesn't do such a great job in this case. It thinks it's only going to get 4 rows, whereas we know there's going to be 200. That's because by default, the optimizer doesn't have a great understanding of the correlation between columns. And I've architected this example to actually, create the optimizer mistake. What happens if I create an index on those two columns? Now when I ask the optimizer what the estimate is, you can see its estimate is actually spot on. Now, critical to this discussion, it didn't use the index at execution time. You can see that the plan there is table access full, but it managed to use the statistics on the index to actually work out a better optimization plan. So if I was to drop that index, I would actually get a bad optimizer estimate on that query. So in this case, it's not only the index is important at pars and execution time, the index stats might be important in their own right. Now, obviously we could work around this without having that index. We could use extended statistics. I can simply go through the process of creating extended stats, regathering statistics, and now without the index, the optimizer still gets the correct result. But I suppose what I'm saying is, index monitoring will help your brain make smarter decisions. It's not meant to replace the decision-making process. Just be careful when you use this because it's complementing your decision making, not replacing it. Let's get on to number 5. In memory. Now, in memory came out in 12.102, and obviously at Open World we made a big fuss about it. And even though I've got my Oracle hat on now, even before I had an Oracle hat on, I was outside the company. I think in memory is just awesome. I've seen so many examples where it just absolutely transforms analytic queries. It's an incredible piece of technology. Now, obviously, when it came out, everyone got very, very excited about that, right? Because some of the demos we saw were just mind-boggling. In fact, I've almost never ever seen a demo where in-memory doesn't make things better. Sometimes it doesn't make things better as much as people would like, but the reality is I've never seen it make things worse. I've always seen things improve within memory. But of course, when you get excited about a feature, what tends to happen is we tend to have some little accidents, and especially if we rush in and use it. The first thing that we often saw was people would choose a poor initial size for in-memory. Now, I'm not being critical here. This is actually often a result of the way the DBAs tend to approach things, which is a good thing, which is we use caution. So if I'm using, say, the in-memory feature for the first time, what I might do is set the in-memory sizes quite small. In this case, I've set it to 1 GB, bounce my database, and then I might do some testing. And this is a cautious approach to make. So I might put my table called my really big table into the in-memory store. I do a query, it runs in, say, 1 second, and I have that great excited moment that, yes, this in-memory thing really works. I'm very pleased. Now I'm going to go back and make my in-memory pool a much more reasonable size. And then we hit the first problem, which was, unlike any of the other memory pools, the in-memory size in 12.102 is fixed. You can't change it without bouncing the database. Now, for those who are new to Oracle, that might not be such a big thing. For those that are old to Oracle, like myself, that might not be such a big deal because we come from a day when almost any memory pool changes require to bounce to the database. Those who are newer to the technology are probably more used to the fact now that any kind of memory pools can be resized without any outage at all. So to fix it, you encounter the second problem. And the second problem was the cost of restarting the database when you have the in-memory store. If we look at a typical picture of the SGA that we see in many manuals, books, blogs, etc., we've got various memory pools within the shared global area. When you bounce the database, obviously we throw all that memory away. When we restart the database, incrementally we repopulate those various memory areas. And it's not really such a big deal. Obviously we lose some of the benefit of the buffer cache and we're going to incur some parsing overhead as we repopulate information into the shared pool. But it's done on a on-demand basis. We don't go populate the buffer cache just for the sake of populating it. As queries get run and data gets read in off disk, we populate those various pools and it's effectively smoothed out. The in-memory store is quite different. The in-memory store is not just a copy of data that's on disk. the in-memory store is taking rows off disk, transposing them to columns, deduplicating values, restructuring the data, performing more compression algorithms on it, and then putting it into in-memory. That stuff doesn't come for free. You actually have to burn a lot of CPU to do that. And in fact, in the early versions of in-memory, people would see that their CPU would be absolutely going through the roof every time they restarted their database when they had an in-memory store. Because we had all these little background work processes actively running off, dragging that data off disk, reformatting it, compressing it, and sticking it into the in-memory store. In fact, we introduced a parameter to actually be able to throttle that back, and by default, we only used half the available CPUs, which is obviously still a big chunk of them, to actually repopulate the in-memory store. So in 12.2, what we've done is we've worked on some improvements to this. The first thing is to fix up the initial sizing of the in-memory. You can now grow the in-memory area without having to restart the database. It has to be in chunks of 128 megabytes, and you can't shrink the in-memory size. I don't see that as a great restriction because most of us will start off with a cautious initial size and then slowly grow the in-memory area as we go. Here's an example of that in use. My in-memory size here on this laptop is 256 megabytes. I can simply do alter system, set in-memory size of 512 meg, and the memory size is grown by poaching some memory from one of the other areas. So you don't have to bounce the database now. And in particular, that's not going to incur that big CPU cost in bouncing the database to repopulate the in-memory store. The other thing is, even if we can grow the in-memory area, there's going to be other times when you're going to need to bounce the database. Security patches obviously become critical, and so each time we bounce the database, we still have that risk of a big CPU slog on the system when we repopulate the in-memory store. To fix that, we now have a thing called in-memory fast start. What will happen now is as your in-memory area is being used in the systems, at regular intervals, we will dump the in-memory area down to disk. All right, that is effectively a copy of the binary image, effectively from the in-memory area down to disk. What happens now is when we restart the database, we can drag that area back into in-memory, and that is effectively a representation of the already compressed and transposed data. So we bypass a lot of the CPU effort in dragging that, putting it back into the in-memory area, and then a little bit of tidy up before we can actually get the system up and running again. So it's a much lower CPU cost. How do we do that? Very, very easy. We actually use our own technology. We use DBMS in-memory admin fast start enable, and we nominate a table space into which this binary image is going to be stored. Now, when I say the term binary image, how do we store binary images in Oracle? Pretty simple. We store them as a blob, and that's exactly what we do. We create a lob, or a blob segment, a secure file blob, in which this in-memory store is dumped, or an image, a representation of it, such that we can drag it back off disk into in-memory after a restart. A quick sidebar on that. You may have heard about this thing called the cloud. I'm sure it's you may have just heard the occasional mention to it at Oracle talks, etc. Obviously, it's a big deal. Believe it or not, people say, all throughout India in the last couple of weeks, one of the most common questions that came was, if everything's moving to the cloud, is that going to cause me problems? Am I going to be out of a job? Am I going to, is it going to change my career, etc.? If you've only got on-premise databases, believe it or not, I think that having the cloud out there is actually really good for those existing databases you have on-premise. Why is that? Well, the biggest Oracle customer now in the world, the biggest user of Oracle database technology is probably Oracle, because we have to look after all those cloud customers now on our own technology. We've become very like-minded. Most companies out there now are trying to squeeze every last drop out of their servers to avoid spending money on resources. We're the same now. If we're going to make money as a cloud company, we want to actually make sure all our servers are very efficient, minimal CPU overhead, and we can do things like patch them and stuff like that without taking outages. A lot of the technical changes you see in 12.2 are so we can be a better cloud company. But the best thing is, if you're an on-premise person and you never use cloud, you'll still inherit those benefits. So people say that cloud is going to create sorts of problems. I think cloud is going to be good even for on-premise customers because it just makes us all like-minded. We want to get the best out of our server resources and have minimal outages. Number 6, the optimizer. In 12.1, we introduced this thing called the adaptive optimizer. we would change plans while queries were running, from nested loop to hash join, for example. We would learn from previous executions and use that information for subsequent executions to perhaps change the plan. We would automatically add column groups on the fly as we detected correlations. We might automatically add SQL plan directives. We might automatically collect stats when we load tables from empty. All these things are very, very cool. The problem is people would upgrade and so much had changed that they encountered some problems. In fact, one of the most common criticisms we had is the very definition of the word adaptive means the plans keep changing. People were worried about that. We sort of got into this awkward game of, similar to what I used to call whack-a-mole, where you would be sitting there trying to fix one problem and you'd fix that and the next day it would be back in some other different form. All these different things you had to constantly go back and revisit. The definition of an optimizer sometimes is not about being adaptive. It's about being stable, even if that stability means we're not exactly optimal. All of this was controlled by one single parameter in Oracle 12.1, optimizer adaptive features. And because people had a bit of pain, what did they do? Well, they turned that off, right? Or they went back to optimizer features enables equals 11204. I want to stress that if you're having problems on 12.1, the optimizer team endorses that. There's no problems. People think, oh, I'm being bad by turning off the features, whatever. Right? It doesn't work that way. If optimizer adaptive features off helps you get better performance on your 12.1 systems, you should do it. It's endorsed by the team. This is probably where we went wrong. Databases tend to sit between very complex SQLs at the far right there and simple SQLs that are very, very time critical. We probably pitched 12.1 somewhere at this area where the red arrow is. A little bit more too far toward the trying to make complex SQLs run as good as possible. In 12.2, we've made an adjustment. We've simply moved that arrow where we think most databases are. That is right in the middle of the spectrum, such that we have a nice balance now that we can offer between an adaptive optimizer that gets smarter over time versus a stable optimizer. So we're trying to find that balance between the two. What we've done is the optimizer adaptive features parameter is now obsolete. It has been replaced with two. Optimizer adaptive plans at the left there. What that is for a given plan that's running, can we change it dynamically at runtime? That's generally low risk because you've already commenced the execution of the SQL and we might want to actually just toggle it to a hash join, for example, from nested loop. The other one is optimizer adaptive statistics. That was the one that introduced perhaps a bit more pain for people, the concept of learning from a previous execution so a plan would mysteriously somewhat change on the next execution. In a reflection of that balance between stability and adaptive, what we've got is the defaults for those two new parameters are true for the less risky one and false for the slightly more risky one. So we have a nice balance now, hopefully in 12.2. If you like that, you can apply a patch 22652097 and get that same split now on 12.1. So you can have that facility on 12.1 now as well as 12.2. One of the things I do stress though is I'm not out here to bag the optimizer people, because the reality is if you've got a system that's running really, really well on 11G and you upgrade to 12.2 or 12.1 and have problems, well, I think you have to cop a bit of responsibility for that yourself, because in 11G we have SQL plan management. You can grab a representation of all the existing plans in your system and ensure that those plans are still used when you upgrade. SQL plan management, the whole database, and then you upgrade and reuse those same plans. So if you've got a system which is running great on 11G, lock the plans down and upgrade. You'll get the same plans in 12. If you have a system that's running like rubbish at 11G, then the adaptive optimizer is probably a great step for you, because it's a new version of the optimizer, effectively a lot of significant changes, and so there's a very good chance things are going to go better for you. So I think you can have your cake and eat it too, as long as you're disciplined on where you are at the moment. A couple of upgrade considerations, even if you're not doing any adaptive stuff. If you're coming from pre-12.2, be aware that histogram types are different, and there's plenty of content out there in the blog sphere about that, and global temporary table statistics handling is different now. So be aware that even if you do turn off the adaptive optimizer stuff in 12, you are going to have potentially some different plans based on the new technologies for histograms and global temporary tables. Number 7, security. Amazingly, hardware outages don't seem to be such a big deal anymore. I always find this very strange. Recently, you might have seen that Delta had a huge computer outage, and there's been various outages that are very well publicized in the press. Google Cloud had a bit of an outage, Amazon had an outage, Microsoft Azure had an outage, etc. It's funny how that when people have those kind of outages, big hardware outages that are high profile in the press, they don't cause people to leave the company. Just because Delta had a computer outage, I'm still going to book a flight on Delta next time if it suits me. People tend to forgive and forget. What they won't forgive you for, what they won't forget, in fact, what will kill you is if you get hacked. Security is now much, much bigger a deal than almost hardware outages. Availability is actually not defined by your hardware in it, it's defined by your security. In fact, we had some famous ones here in Australia. Our census website got hacked. In fact, the rumor is it was just an overload, but effectively denial of service. We had some companies that actually have been entirely put out of business. And this becomes one of my favorite quotes now, is that it's actually consumer trust. Consumer trust in your level of security is the new definition of high availability. Now, hopefully that sounds like a really profound quote, because the reality is I just made it up. But you get the idea. Security trumps hardware availability nowadays. Now, the problem with security is it's not easy. If you go to any Google site and type in, for example, security checklist for DBAs, you get thousands or pages and pages of things that you meant to be checking for just to make sure that your security passes the most stringent of activities. It's a lot of work for a DBA to do. What we've done to try and help you with that now is a tool called DBSAT, Database Security Analysis Tool. What happens is you run the facility in what we call a collection mode, and that simply collects some information, connects to your database, picks up lots of information, and then you run it in what we call a reporting mode. It uses that collected information to produce you a report. When you go look at the report, it's a bit like an AWR report in the sense that it's full of hyperlinks. You can jump back and forth between it and pick up lots of information about where you're currently perhaps falling short on security. It doesn't go change or fix the security things, but what it does is actually tells you where you need to focus your efforts. And obviously, if you do tick every single box, that's a great document now you can give to your auditors to say, this is showing that we are due diligent, at least to a reasonable degree, in terms of our security process. The other thing that's good with DBSAT is it's free. Yep, 100% free. Now you might be thinking, that's got to be a typo. We got an Oracle guy on the webinar line telling us that we got some free software available. But it's true, it's free. It came out around 12.2 time, but it's actually just a set of scripts. You can run this on any version of the database from 10.2.05 onwards. So you can download it from My Oracle Support right now and run it on all your existing databases. You don't have to be on 12.2 to do it. The other part of security that's obviously critical is encryption. As we know, if we have a database, it should be encrypted. It should be locked behind closed doors. Not just in terms of access, but the actual data itself. A lot of people forget that the Oracle database, when you take away all the technology and all the complexity, is just files on disk. So here's my table called My Important Stuff. It's got a credit card, and there's my credit card information in there. That's gone into, say, the user's table space. People forget the fact that sitting there in my user's 01 data file out on disk somewhere is my credit card just in plain text. I just run the strings command on it in Unix, and there's my credit card details. That's in the tablespace data file. It's also possibly in my backup data files. It's also possibly in my data guard node. It's possibly in my offsite backups as well. It's a problem. You don't ever want to have unencrypted data in your database. And in particular, that's why every database on Oracle Cloud is encrypted by default. We want transparent data encryption. That solution has been around for a long time to do it. There's been a slight problem though. Most of us create databases and then decide to encrypt them. And we end up having to send these very, very awkward emails to our bosses. We say, hi boss, we didn't encrypt the database when we first started, and we found out from a presentation, hopefully this one, that all our data is potentially exposed. Easy to fix. All we have to do is have all our systems down for the next 3 days. Because up until 12.2, encryption had to be actually done offline. In 12.2, transparent data encryption can be done online. we simply create our key store in the wallet exactly as we normally would. That's unchanged as before. And this is how encryption works. I do select name from VDOLA data file, and there's my unencrypted file, u01 oradata mydb users01.dbf. It's a one-liner command, alter table space users, I'm doing online encryption, and I've given it a file name conversion string. What we're going to do is copy that source file. While we're copying it, we'll be encrypting the data, and then we'll do a dictionary manipulation to actually flip the data file over. So once the encryption's done, there we have u01 oradata mydb users underscore enc01. It's an encrypted version of that file that's been encrypted online without any interruption to service. If I rerun the strings command on users enc01, you can see I can no longer see my credit card details, and I have a lot more faith in this database. Number 8, QTF-WBC. It sounds like a new acronym, right? But it's actually my acronym. Queries that finish without bloody crashing. Let's say we have an insert into my table and I'm doing a query from select my whopping great fat table. That's a huge table. So once I run that in the SQL Developer, what do I see? I'll see that, the hourglass. And I'll see it for a long, long time. I might get a coffee, I might do some internet banking, but the whole time my SQL Developer session is just sitting there busily humming away at that insert statement. Eventually, 6 hours later, after I burnt my whole day trying to get this thing to run, there is nothing worse than then seeing an error message. Because you simply say, no, how could this happen? I've just burnt all that time. And funny enough, even though we're database professionals, we know that transaction consistency means an insert works or it doesn't. All our stuff is now just gone down the toilet. But still, what we'll do is we'll still jump on the system when something is run for that long. When something is run for 6 hours, we'll still jump on and say, please, let's just do a count of my table. Please let some of that data have made it through. But of course it's not. It's gone and gone forever, and you've simply wasted 6 hours. In 12.2, we have a new function called validate conversion. Let's see what the cause of the problem was in that insert statement failing. I had a column called created date. It was actually a varchar 2. It was being converted to a date as we loaded it in. You can see there, one of the rows there has some dodgy data. It's 54th of August is a date that obviously cannot exist. Someone put some erroneous data in there, and it only takes one bad row to actually make a mess of that whole insert statement. In 12.2, we have this validate conversion feature, which simply says, rather than crash when I perform a date conversion, I'm saying take my created date, try convert it to a date using the format mask DDMONYYYYY. If I can convert it successfully, return a 1. If I can't convert it successfully, return a 0. So you can see for that query, I've actually removed from consideration that erroneous row of 54th of August without the query actually crashing. Similarly, the cast function has been extended in a similar way. If I want to actually preserve that erroneous row, but map it to a default value if I can't convert it, here's a similar example. I've got my salary column down the left there, and someone's put an erroneous comma in there as a varchar 2. That can't be converted to a number by default, so it doesn't work. But my cast function has now been extended. I can do cast salary as number. I can say, if I convert it to number, then fine. If I can't, on a conversion error, then return -1. So now I can keep the erroneous row, unlike validate conversion, but actually return a default value as well. ToNumber has had the same treatment. You can do the same thing with ToNumber, and in fact, all the two functions, ToDate, ToNumber, ToTimestamp, have now been extended such that you can assign them a default on a conversion error rather than the default behavior of them crashing. Number 9, outages. As I said before, sometimes outages are unavoidable. We have to do them for security reasons. But let's be very frank in here. Outages suck, right? Nothing gets your management upset more than you repeatedly going back to them saying, can we take the system offline to do this, to do that, do whatever. And very quickly, you start losing the right to do them, and the next thing you know, you've been hacked because you didn't put some security patches on. In 12.2, you can just about do anything online. Now, I know there'll be some skeptics out there, and I'm obviously a skeptic as well because I've been in the industry for a long time. Generally, every time there's been an Oracle release, since as long as I've been alive, someone gets up and says, everything can be done online now. And what they really mean is, we've made a couple more things online. 12.2 is probably the closest I've been to where I've seen there's very little you can't do online. A whole lot of work has gone into this area. Let's look at some examples. Here's a table called T. It's just a standard heap table with an index on it. In all versions of Oracle before 12.2, you can't do an online move at all with that table unless you use DBMS redefinition. I've created some transactions, some active transactions on that table, uncommitted, and then I commence the following: alter table T move online. It commences working, but it'll sit there and wait for those uncommitted transactions to commit. When I commit those transactions, the alter table move online finishes. This is a heap table, remember, and what's more, the index on that table remained valid. It didn't become unusable. So now with a stock standard heap table, I can move it online, no interruption to service, and the indexes can be kept valid at the same time. Let's up the ante a little bit. Let's try find a more complicated example. We can do composite operations. Here's one where I'm going to move my table called sales. I'm going to compress it. I'm going to put it in a new table space called users. I'm going to update 2 of the existing indexes on it. Those indexes are going to go into new table spaces as well, and I can still do the whole thing online. No interruption to service. Very, very cool. Let's talk about big data for a second. Now, I know big data is one of those hyped things that, when people start saying, please don't talk to me about big data because I've seen so much about it of late. But before we talk about big data and that terrible thing called the 4 V's, which we used to have pushed down our throat, volume, velocity, variety, value, or as I say, blah, blah, blah. Before big data, as DBAs, we have a bigger problem, or I should say, a problem that we have to solve before we get into big data. Before the 4 V's, we have big data is just my data is getting too damn big. So forget about unstructured data and stuff like that. It's just managing the continuous growth of our existing systems. So it's not really about the 4 V's, which is all about big data in the classical sense. I think of it more in terms of the 6 P's. What does the 6 P's mean? When data becomes painful to back up because it's so big. When it becomes painful to manage because it's so big. When it's painful performance because it's so big. We probably should partition it. That's the 6 P's. And when you have the 6 P's, it's generally followed by the 2 O's, which is, oh, crud. We're going to need an outage to do that. And in all versions of Oracle, to convert a table to a partition table requires an outage. In 12.2, you can partition an existing table with a single command online. Let's explore just how cool this is. Here's my table called T. It's 20 copies of DBA objects. I've got a couple of indexes on it, IX and IX2. I'm going to modify my table. I'm going to make it a partition table. I'm going to partition it by range on the object ID. In fact, it's going to be an interval partition table as well. I can use that as well. Take the indexes. One of those existing indexes, I want to become a local index partitioned, and I want to put it in a brand new table space as well. The second index, I'm going to partition it as well, but not locally. It's actually going to be a different partitioning system to the table. I'm going to globally partition by range on created, and I can nominate the partitioning ranges I've got there. Oh, and by the way, while I'm doing that, I'm going to only consider the rows that I've picked up in the last 7 years. I'm going to archive off the rest. They're going to get discarded, and I'm going to do that all online in one command. That is how super cool some of the online operations in 12.2 are. It's really, really hard to find things you can't do online. I'm really excited about the online stuff. Number 10. This might be our last feature, I think. Oh, well, we might go get one more in after this. One row. One lousy row can really spoil your day when you're a database administrator. Let's look at the following query. It's a fairly simple query. Select owner count star from T group by owner, where owner like S%. It's running for a long, long time. As a database administrator, when we get the call and say, can you see why that's running for a long, long time? Well, we say it's fairly obvious. If I go look at my table, it's got 7 billion rows in it. And there's no real indexing strategy that's probably going to help me greatly there with 7 billion rows of data to sift through. This is what we might do as database administrators to try work around the problem. Rather than totally change the structure of the database, let's effectively pull the wool over the user's eyes. We'll create a materialized view log on the table called T and create a query rewrite materialized view such that when they run that long-running query, the execution plan looks something like this. We're not actually visiting that massive table called T. We're actually rewriting the query under the covers and accessing a materialized view called T_MV. When this happens, you are just a hero in your organization because you took a query that ran for like 12 hours and now it runs like sub-second. You're like materialized view man, like a superhero, and everyone loves you. Next thing you know, you're getting the employee of the month and you're getting the plaque on the wall and the coffee cup and stuff like that. Until something happens. Now, a table that's got 7 billion rows in it is probably going to get lots more rows in fairly quickly. And in fact, all it takes is one row. I just insert one more row into that table and my materialized view is now stale. Now when I run my original query again, I'm back to table access full without the rewrite. That is like kryptonite to the superhero that you were. No one wants that employee of the month plaque on your desk anymore. In fact, they want to kill you because you've actually made things worse. Now when the materialized view is fresh, the queries are fast. When it's stale, the queries are slow. It's become random performance. This is what we used to do sometimes. We'd simply have this very aggressive loop of trying to refresh the materialized view to minimize the amount of times it was actually going to be stale. In 12.2, we've introduced a thing called real-time refresh. This is not the same as an on-commit refresh materialized view. Let's look at the new syntax. The key clause there is enable on query computation. I've recreated my materialized view and now it's fresh. So if I look at the explain plan for my select against my base table called T, you can see I'm using the materialized view rewrite. That's just as before. It's a fresh materialized view, rewrite is happening. Now I reinsert another row into my table called T. This makes the materialized view stale. When I run my query, it's still very, very fast, 1.4 seconds. If I turn off rewrite and sit there for 12 hours and run my query, I still get the right answer. So the question becomes, how did I do a materialized view rewrite with a stale materialized view? How is this possible? It's a 12.2 facility. One thing I stress, we didn't actually refresh the materialized view under the covers. If I look at the data here, the correct result is 50941. If I go query the materialized view directly, I get 50940. It is genuinely stale, and yet I still managed to use it to produce a fast query. If I do an auto trace on my base table query now, the execution plan looks far more complicated. What we're actually doing is doing the same operations that a refresh would do, but just for the sake of this query. We're going to the materialized view log and grabbing the inserts, going to the materialized view log, grabbing the updates, and going to the materialized view log, grabbing the deletes, and for the purpose of this query, just merging them into the result set. Now, if the materialized view gets left stale, what if I do a direct query of the materialized view? We have that 50940, which is one row incorrect. I can actually use a new hint in 12.2, fresh MV, to actually freshen up the materialized view as well. So it's a really cool way of actually having materialized views refreshed without burning a lot of undo and redo at the same time. It's on query computation. Let's now talk about our last feature for the day because it's 6 p.m. in my time. Now you might be thinking I'm going to talk about something huge, and let's face it, the biggest feature in Oracle 12.2 is probably sharding, the ability to present multiple physical databases that might even be geographically distributed as one logical database. But I'm not going to finish that because sharding is, don't get me wrong, is very, very cool. Lots of availability, incredible scalability when we talk about sharding, and there's plenty of information out there about sharding. But let's be realistic here. Every startup company in the world thinks they're going to be the next Google, the next Facebook, the next Oracle, the next huge company. So they all think they're going to need, infinite levels of scaling and availability, and hence sharding. This is the reality. The reality is 99% of startups fail. In fact, the vast majority of startups will disappear, or even if they are successful, you'd be amazed what you can achieve with just a nice single box running Oracle. You can do insane levels of performance on modern hardware. You often don't need sharding, it's just an overcomplication. So I'm going to talk about something that's very small but very dear to my heart. The SQL Plus command in 12.2 now has a history option. Now I know that probably doesn't get you as excited as I am about it, but then again, I'm almost a 30-year dinosaur with Oracle, so I'm very, very thrilled about having a history command. All the commands, including SQL Plus commands themselves, are actually recorded in a history. You can bring them up and edit them, history number 2 edit, and actually edit the commands and rerun them, or you can simply rerun them, etc. History command in SQL Plus, I love it. The other thing which I think is long overdue is in SQL Plus 12.2, you can do set markup CSV, and now queries come out as a comma-separated file. No more, as one of the most common questions in AskTOM is, how do I use util file to unload a CSV? Now you can do client-level unload just with set markup CSV in SQL+. We also have a thing called turbo mode in SQL+. Now, if you're as old as I am, you remember PCs that used to have a turbo button on them, where they'd run a little bit hotter and a little bit faster. In SQL+, obviously we can't make things just run faster, but turbo mode effectively turns on some basic parameters to improve the speed of fetching data across the network or from the database. So it's a way, if you're unloading data using set markup CSV, you can turn on turbo mode using -F to actually get some, hopefully, performance benefits. Obviously, don't forget SQL CL, it's the logical successor to SQL+. Okay, it's 6:03 my time, so we've used up the hour. Apologies for the latency. Obviously, that's probably the fact that I'm in Perth and carrier pigeons normally do the network in Perth, but we'll wrap it up. There's a huge amount in 12.2, right? Obviously, lots we didn't even cover today. There's a massive amount. There's over 300 features in 12.2. Lots and lots of stuff that I hopefully you're as excited about it as I am about. I'm so lucky being inside the organization that almost all our databases are 12.2. Hopefully, this will inspire you to get playing with 12.2 and working on 12.2. When I came home and told my young son that 12.2 was released, hopefully you can see on the screen just how excited he was, right? It's a fantastic product. I really enjoy working with it. Just to finish off, that's my Twitter handle, Connor_MC_D. Please follow me if you're not on Twitter. Love to get in touch with you. All these slides will become available. Thank you very much for your time and putting up with the issues in terms of network latency. I've really enjoyed talking to you all. Get in touch with me on the Facebook, Twitter, blogs. Love to catch up. And the slides will obviously be shared in due course on asktom.oracle.com. Thank you very much for your time. If you can see that slide, it's Aura 3113, which is end of communication channel, and that is the end of mine. Thank you very much for joining. Make sure you come back in a couple of days for the next in the APACOUC series. Thanks everyone for your time.